All right, the next question for problem set 2, question 2, is much trickier. So I'm going to try to break it down as best as possible. So we have a mixture containing potassium chlorate, potassium carbonate, and potassium bicarbonate. This HCO3 is bicarbonate. And potassium chloride. All 4 things of these were heated, and CO2, oxygen, and water gases were produced. But the chemist knows the different types of decomposition reactions that are happening. So for potassium chlorate, it will decompose into potassium chloride and oxygen gas. Potassium bicarbonate will decompose into potassium oxide, water, and carbon dioxide. And potassium carbonate will decompose into potassium oxide and carbon dioxide gas. So we have 3 different equations that we have to look at. We don't have to use them all at once. We just have to know these for reference. So the question says the KCl, potassium chloride, does not react under the conditions of this reaction. So we don't care about that for now. If 100 grams of the mixture produces 1.8 grams of water, 13.2 grams of carbon dioxide, and 4 grams of oxygen, what is the composition of the original mixture? So this is tricky. We have to look at these elements here, these compounds here, and know how am I going to use this information to figure out how much of each original reactant we have. So what I'm going to do is I'm going to start by doing process of elimination. Which chemical reaction only has water in it? This doesn't have water, so I can't use the information for this first reaction. This has water, so I can use this information for this first reaction. And this one does not have water. So it looks like I have to start with this one for H2O. If I know the mass of water produced, I can figure out the mass of potassium bicarbonate that we start with by using law of conservation of mass, assuming we have a perfect reaction. So I'm going to stop and solve that for now. So if I have 1.80 grams of water, I know 1 mole of water, it weighs 18.02, that's the molar mass. And now I can do my molar ratios. For every 1 mole of water, I started with 2 moles of potassium bicarbonate. Now, because this is the composition of the original mixture, I'm going to go ahead and find the mass percents of everything. So here, I'm going to go from moles of potassium bicarbonate to grams by using the molar mass. Okay, there's my molar mass. My moles cancel. Moles of water cancel. Grams of water cancel. And I get 20.00 grams of potassium bicarbonate. All right, let's see what else we have. Okay, so now that I have 20 grams of potassium bicarbonate, let's look at CO2. So I see CO2 in both this one and this one. So it'd be really hard to figure out what's going on with carbon dioxide if I don't even know where it's coming from exactly. So I'm going to save that till the end. But let's look at oxygen. Oxygen is coming straight from potassium chlorate. It's the only chemical reaction that has oxygen as a product. So I'm going to use that one next. 4 grams of oxygen. So I'm going to use oxygen to solve for this one. So same thing, I'm going to find the molar mass to get to moles. I'm going to use my molar ratios. For every 3 moles of oxygen, I produce 2 moles of potassium chloride. Oh, I started with 2 moles of potassium chlorate, I'm sorry. And then I want to find the molar mass of potassium chlorate. So let's see, it is 122.55. Okay. So now I will know my mass of potassium chlorate. And I got 10.21 grams of potassium chlorate. All right, so we got the potassium chlorate. We've got the potassium bicarbonate. We have two more we have to find. So the next part is kind of tricky. It's because we have two remaining things, one doesn't react, but one does. And the product of this one is CO2, which is also a product of this top reaction, or this middle reaction here. But fortunately, we already know how much potassium bicarbonate we're starting with. So we can work backwards. We can say if we are starting off with 20 grams of potassium bicarbonate, how many grams of CO2 are being produced? And the remainder must be coming from potassium carbonate. So that's what I'll do there. So I'll start with my 20 grams that I've already solved in the first equation that I did. So if I have 20 grams, I'm going to get that to moles. We already solved the molar mass in the first line of equations. Okay, so for every 2 moles of potassium bicarbonate, I get 2 moles of carbon dioxide. Oops, HCO3, 2 moles of CO2. And now I can figure out how many grams of carbon dioxide is coming directly from this reaction only. Okay, so let's tell you, sorry, I'm running out of room here. So 20 divided by 100.12 times 44.01. So 8.79 grams of carbon dioxide is coming directly from this second equation. So if I have 13.2 grams of carbon dioxide that's being produced in total, then the rest must be coming from here. So 13.2 minus my 8.79 is 4.41 grams. So now I can work backwards using stoichiometry here to get to this guy. So let's see, running out of room here, so I'll do it on the top. So 4.41 grams of carbon dioxide. Of course, with stoichiometry, I've got to get it to moles. So for every 1 mole of carbon dioxide, it weighs 44.01 grams, the molar mass. And for every 1 mole of carbon dioxide, my mole bridge, I need 1 mole of potassium carbonate. And then I can do my mass. For every 1 mole potassium carbonate, let's see, 39.1 is potassium plus carbon plus 3 oxygens. So I got 138.21 grams of potassium carbonate. Great. Now I can figure out how many grams of potassium carbonate I have. Okay, going through here. So 138 divided by 44.01 times 4.41, so 13.85. 13.85 grams is potassium carbonate. All right, we're almost done. So 13.85 grams is potassium carbonate, 20 is potassium bicarbonate, 10.21 is potassium chlorate. So I got 3 out of the 4. And the last bit of information is that I have a 100-gram sample. So I need to figure out about this KCl because it didn't react with anything, so I don't need to do stoichiometry with it. I just need to add up these masses and then subtract from 100. So 13.85 plus 20 plus 10.21 gives me 44.06. So 55.94 grams must be my KCl. That's a really good problem. I like it. Like it so much, maybe it'll be on your quiz. I don't know.